I think it's recording. I can't. Yeah, it's recording. All right. This is the extra credit for which one's more acidic. And I chose HClO2 and HFO2. And first things first, we need to find the valence electrons. Hydrogen is, I think it's a charge. Charge is 1, chlorine is 7, oxygen is 2, so it's 12. And then that comes out to, when you do the math, 8 plus 12 is 20. So then we just go ahead and draw it. So we do chlorine right here, a double bond for this oxygen, satisfy that. And then there's this oxygen, and then there's a bond right here for hydrogen. And then there's 1, 2, 3, 4, 5, 6, 7. So there's 2 lone pairs for, or 4 lone pairs for chlorine. And that satisfies the valence electrons. And so then we just gotta do the formal charge for all the molecules or whatever in the structure. So the equation for the formal charge is formal charge valence electrons minus unbonded electrons minus the bonded electrons over 2. So for hydrogen it would be, where is it? It would be H times or equals 1 minus 0, since there's no unbonded electrons, minus 2 over 2, which all comes out to 0. And then the oxygens are 6 minus 4 minus, there's 1, 2, 3, 4 bonded electrons over 2, and this comes out to 0. And then the chlorine has 7, and there's 4 unbonded electrons, so you do minus 4 minus the bonded electrons, which is 6 over 3, and that comes out to 0. And if it's all zeros, then that's good. So then we find the conjugate base for this acid, which is ClO2 negative. And then you do the valence electrons for that one, which is 7 and 12, because there's 2 oxygens. But since it's a negative, you gotta add 1, which comes out to 20 again. So then we go ahead and draw this one, which is Cl with those oxygens, a double bond on that oxygen, and then a single bond for this oxygen. But then this has 7 because of the negative, so you put the negative charge right there. We do the valence electrons, now we do the formal charge. I'm gonna do this. Formal charge for this one would be the Cl is, oh shoot, whoops, there we go. 7 minus unbonded, there's 4, minus the bonded, which is 6 divided by 2 equals 0. And then I'm gonna label this one oxygen 1. So oxygen 1 is 6 minus unbonded 4 minus the bonded, which is 4 over 2, which gives a 0. And this is oxygen 2. So this one has a 6 minus unbonded, which is 6, minus the bonded, which there's 2 divided by 2. So that comes out to negative 1, which makes sense because it's a negative right there. So now we're gonna do the same thing for HFO2. Valence electrons for this one is 1 plus 7 plus 12, which comes out to 20. This one, we go ahead and draw that. It has a similar structure. Only thing that's different is this one has fluorine, this one has chlorine. So yeah, same structure. That oxygen bonds with this hydrogen, 2 lone pairs on the fluorine. And then formal charges for this one would be for fluorine is 7. That's the on the periodic table. It's like the row. Fluorine's right here, and this is 7. And then we do 7 unbonded is 4, bonded over 2 is 6. No. Yeah, that makes sense. 3 minus 3 equals 0. And then the oxygens are 6 minus unbonded 4 minus bonded, which is 4 over 2, gives us 0 as well. And then the hydrogen, which is pretty much a constant, 1 minus 0 minus 2 over 2, because hydrogen has 1 on the periodic table. And then there's no other like lone pairs on it, so it's 0. And then there's only 2 bonded electrons right there, which makes it 2/2, which gives us a formal charge of 0, 0, 0, which is good. And then the conjugate base for this would be FO2 negative, which it just uses hydrogen. So then we find the valence electrons for this one, which is fluorine has 7, oxygen is 2, so it's 6 times 2 is 12. And then since it's a negative right here, we have to add 1. So we get 19 plus 1 is 20, same as that one. We go ahead and draw this one, which gives us fluorine, double bond on the oxygen right here, single bond on this oxygen, but this one would have negative to satisfy it, I guess. And then we just do the formal charges for this one. So the flow, 1, 2, 3, 4, 5, 6, 7, yes, that works. Formal charges for fluorine would be same, it's a 7 minus unbonded 4 minus 6 bonded over 2, which gives us 0. And this will be oxygen 1 again, so we'll do O1, which has 6 minus unbonded 4 minus bonded 4 divided by 2, which gives us 0 again as well. Oxygen 2 would be 6, because this is the number of valence electrons, minus unbonded, which is 6, minus bonded, which is 2, over 2, which gives you -1, and that checks out because of that charge. So now this is where we find out which one is more acidic. There's 3 ways. There's resonance structures, there's resonance structures, there is size, and then there's electronegativity. So now we're doing size, and we're only looking at the ones with the negative charge on them, so that would be oxygen for FO2, and that would be also oxygen for ClO2. So they're both oxygen versus oxygen, both are the same size, so you just put same, can't really tell which one's more acidic off that. Then you go to electronegativity, and then so you would get the electronegativity, we'll do ClO2 for this column. So the oxygen, so you can get the electronegativity off the periodic table, and for oxygen it's, I'll put it up here, 3.44, and then chlorine, you would do the neighboring atom, and the neighboring atom is chlorine for ClO2. And the electronegativity for that is 3.16, and then you just find the difference. And then for FO2 negative, oxygen is the same, 3.44 for its electronegativity, and then fluorine has an electronegativity of 3.98. So you do that, find the difference. I think I did the math for it. ClO2 is 0.28, and the difference for FO2 is 0.54. ClO2 has a small electronegativity, so it makes this one more stable. And I think more acidic. Yeah, so ClO2 just off the electronegativity would be more acidic. So for now we can just put where, I don't know what I should put. ClO2 more acidic. We would do resonance structures. However, they are pretty much identical when it comes down. Like ClO2 would be chlorine, that single bond with the negative oxygen, and then double bond on this one. And then for this resonance structure, what would happen is this lone pair would come make a double bond, and then this double bond, one of these bonds would come make a lone pair. So then this would go to Cl double bond with oxygen, and then this oxygen right here, which lost its double bond, would become the negative atom, and that would be the same for this FO2, F negative double bond on this oxygen. This lone pair comes, makes a double bond, this double bond makes a lone pair right here. So then you would just, yeah. So then there's that double bond, the oxygen with 2 lone pairs, and then there's this oxygen that gained the lone pairs, making it the -1. So you can't really tell off resonance structures. Resonance, because they're the same. So just off the electronegativity, we can tell that since ClO2 is less in its difference with electronegativity, it would be more acidic. Thank you. I'm done.